Good day and God bless students. In this video lecture, we are going to discuss the topics in CS Elect 2 Computational Science in Module 2, such as the modeling process, the the terms that we are going to use in this uh, lecture. We are going to also define those terms and uh, look look at the examples of the computational science applied modeling. All right, so in in the process of making and testing hypotheses about the models, and then revising the designs or theories has its foundations in the experimental sciences. We know that uh, in the experimentations as a science, this process such as testing hypotheses, the procedures about the models are part of this, and this is the foundation. And similarly, in computational science, scientists, they use modeling to analyze a real world problems in order to predict unsay mahitabo in the future, or what might happen with some course of actions. All right, so here are an example. Example number one. This is uh the a kind of model. This is a model from Professor Monio Hori and his colleagues in the Earthquake Research Institute. No niya na siya nga. They actually use high performance computation with sophisticated models to simulate earthquakes, making quantitative predictions of infrastructural damages, response, and recovery to help minimize damage, death, and injury. So kani siya nga model, this is actually designed especially sa to simulate earthquakes, especially sa Japan, kay rampant kaayo dito ang linog. And uh, what this simulator, or what this model do, is that it predicts the damages, the infrastructural damage, kung kung unsa kadaghanon, no, or the quantity sa damage sa earthquake depende sa intensity sa earthquake, no, and the response and recovery to help minimize the damage, no, para ma-estimate or ma-predict nila uh, ang the type of response, no, for that intensity of earthquake, and how many death, no, this model could actually predict also the numbers of death and the intensity of injury na nga matamo sa isa ka kwan sa mga tao dito on a certain place. All right, so I have here a video, no, link, no, where you can watch. This is actually an example of earthquake simulation in Japan, and you just have to observe no unsay mahitabo ani. But I'll just skip this one to save time. Okay, pwede naman ninyo lantawan on your own. All right, so for the next example, all right, so from okay, si Professor Liming Liang, no. He is a statistical geneticist at Harvard School of Public Health, and who uses a statistical or who uses computational and statistical tools to better understand the genetic variation in complex human diseases such as dyslipidemia, cancer, and type 2 diabetes. Okay, so kani siya, they are using computational and statistical tools. No, they actually gather uh, an a large amount of data to analyze, and using this data they could, after analyzing this data, they have this information that could better understand, no, sa unsay sakit sa tao, no, and they could analyze this disease such as cancer and type 2 diabetes, and to further understand og unsa pay mga medications nga pwede i-apply, or the type of treatment, no, since masabtan nila ang sakit, and then they could come up with a medicine afterwards using this quad model. Okay, and all right, so that's for this example, no. Kanina sa image diary, this is an example model, no. They could actually see in the image, no, uh, a graph. It's not just a graph, but naa na siya kuan, naa na siya uh sito gani, naa na siya analysis, no, from this image sa taas, no. uh, the data from the DNA, ilan ang i-analyze, no, and that data uh, i-feed nila dito sa algorithm, and the program will analyze those data so that it could come up, or it could understand, no, unsay sakit, no, based ato nga data, and uh, they could run a test, or they could train the models para makita nila ang graphs, no, unsay uh, type sa diabetes, or unsay level sa cancer, so inana. Okay, so number 3. Okay, this is from this is from a cognitive scientist, no, professor, such as Professor Ken Koidinger at HCI Institute, no. They develop a computer models of student reasoning and learning to aid in the design educational software and to guide teaching practices. Okay, so this type of model, they could or they studied to, or they use this a model, computational tools and model to develop uh, or force to understand, no, or to develop the student reasoning and learning to aid in the design educational software. So naa sila software nga gigamit. It could be an application or a website that could actually help more sa students, kay since masabtan nila unsay unsay uh, reasoning, or the level of reasoning, and ang learning sa isa ka bata or isa ka estudyante. From there they could be able to design a software, no, to guide the teaching practices, and this is used especially sa mga teachers in teaching this different students. Okay, so here is a website where you can uh, uh, where you can view, no, different uh, tools or educational tools na gigamit. Let's see. So okay, so okay, so here are the list of the educational tools, no. For example, kani si Animoto, it gives students the ability to make short 30-second share video of what they learned in a given lesson. So this would aid teachers to further to teach, no, and assist the students in learning. Okay. All right. So next example is this one. Is what we called as unarmed aerial vehicles, or UAV. No? Both civilian and military organizations, no? They commonly employ drones such as this one, no? Whether to monitor air quality or supervise combat forces. So this technology is becoming more and more important, but the operation of the drones is quite complex. So that is why there's a team from MIT who worked, no, with these models to develop new decision support system, no, or DSS, that will enable the operators of this craft to make better decisions. Kay lisod manggod kaayo nga kulangan, no, the drone itself could not uh, decide or make a decision, since especially if wala siya naka-program, no, to read or to understand variables nga nasa taas, no, such as the objects no matagbuan, or the air intensity, no, and controlled siya, no. This type of vehicles is uh, siguro controlled pa ni siya, there's an operator, but they are actually developing, they are working uh, to develop a model that could uh, or or they are working for a model to develop new decision support system. Okay, so magamit po ni siya for kanang to say to kanang mag mag-survey or maglantaw sa taas, no, unsay status. Because naa ni siya cameras, naa ni siya iyahang kaugalingon nga system. So next, okay, arboroviruses, no, are arthropod-borne viruses that cause diseases such as West Nile encephalitis, dengue fever, and yellow fever. So a mathematical modeling team at the Universidad Nacional Autónoma de Mexico has been modeling the dynamics of such infections. So a better understanding of these viruses will improve outbreak predictions, interventions, and responses. So they have this data, no, kung pila ka buok natakdan ani nga month in the specific area, and this they will use this data to better understand the virus, no. Actually dili lang ni diari sa Mexico, dito sa Mexico ang study, but naana po ni diri sa Philippines, no, gisugdanan ni diri. And uh, this is not just in the field of computational science, but naapoy uh, naapoy data mining application, kay need ni siya og uh, daghan jud nga data, no, to have an or to come up with an accurate information about dengue fever. So these models here you have seen, or in the screen, is that naa siya graph, no, in relation to time, and in relation to the numbers, no, og pila ka bok ang ang nagsakit or naay outbreak aning month, and pila ka bok ang na nagka-fever or nagka-dengue fever or na takdan aning virus. Actually they could do the same with kuan man pod, they could do the same with COVID, no. Pwede nila gamitan og computational science, no. uh, you can by the way search about that, daga na siya manggawas. So isa na siya sa example sa modeling, no, or applied computation. Okay, so here let's define the word modeling. Now this is the basically this is the application of methods to analyze complex real-world problems in order to make predictions about what might happen with various actions. So na-mention na ni ganina, again, application ni siya, no. of different methods, which will be hopefully we're going to cover in the future discussions, which can analyze complex real world problems para predict unsay mahitabo in with these actions. Okay, katong ganina katong na mga graphs na yung mga connected nga mga dotted and connected lines, those are example of model. And uh, na output to siya from ang input ato are data, no, lots of data, and then dagan siya sa algorithm, no, ipaagi siya machine learning baka, and then uh, mugawas na din to siya nga data. So okay, so there are several classification categories for model, and a system we are modeling, it exhibit, no, naa siya probabilistic, naa siya ani nga mga classification, like for example probabilistic, stochastic, or ginatawag nga stochastic. If an element uh, appears, no, by chance, or if it appears that element of chance exists, no, chance lang, no, probabilistic or probability. Now, for example, the path of hurricane, that is probabilistic, no, kung dili, that this is phenomena we are talking about. And this type of disaster, lisod ni siya tagnaon og asa ni siya moagi, asa siya padulong. That is why probabilistic ang system, no, kung ang i-predict niya is dili siya certain, no. Just like mga ina nga example, na behavior ang lantawon, and lisod siya i-predict. So in contrast sa behavior, it can be deterministic pod, no, such as the position of a falling object in a vacuum, no, maghagbong ang object, and the object is in the vacuum, ihulog siya. So obviously ma-determine siya kung asa siya padulong or asa siya dapita mahagbong. So that is for deterministic. So deterministic ang behavior sa isa ka system. Okay, so probabilistic or stochastic model, it exhibits random effects, no, random ra, while ang deterministic model, no, it does not exhibit random, kay kuan man siya kanang certain man siya. So the results sa deterministic model magdepend on the initial conditions, of course, you know, in case of computer implementation, no, in the case sa computer implementation, naa siya input, no, so that it could whatever the input is, o unsa to nga input ang i-feed, that would display the same output, or the output is the same for each program execution, no, bisan pagbalik-balik ko na siya execute, but the same ra in input, mao ra gid gihapon to ang magawas. Okay, so we can also classify models, or models as static or dynamic, no, pwede pod, no. Una, there's probabilistic or stochastic, it's the same, and the second is deterministic, and there's another classification is what we call the static or dynamic. Static or dynamic. So we do not in sa static model, we do not consider time. So that the model is more siya this is comparable to a snapshot or a map. Okay, so for example, since wala man siya time, mura ra kagalantaw picture, no. For example, in the picture nga imong gi-observe, there's a salamander, no, with or there's a model of a salamander with the given weight as being proportional to the cube of its length, okay, and has variables for weight and length but not for time. So makita. So dito mura kagalantag picture makita na to ang iyang weight ug length but not time. So wala siya relation sa time. But sa dynamic or but in continuous model, no, or what you called as the dynamic, yes, uh time changes, no, so that such model is comparable to an animated cartoon or movie. So diari aside sa naa siya weight, naa siya kuan, we could also see the number of salamanders in an area undergoing development changes, no. So aside sa weight sa iyang uh, the length, no, since uh kuan man since dynamic man ni siya, so mo siyang video, no, galantaw ka, and there's you can actually observe, no, the process of the development of the salamander. Okay, so many of the models we consider in this text are dynamic and employ a static component as part of the dynamic model. So si static component siya ni dynamic, no. Okay, so again, a static model does not consider time while dynamic model changes with time. So when time changes continuously or smoothly, ang tawag ana sa model is continuous. So if time changes in incremental steps, the model is discrete. So mura siya og kuan when we say discrete, no. Uh this is a analogous to a movie, no. There are sequence of frames nga manglihok, no, so quickly that the viewer perceives motion. No, however, in a live play, the action is continuous. So, ug maglantaw tag salida na ay mga makita na to nga mga cutscenes, pero in a movie, although mura siya og uh, mura siya og nang sumpay, but kay nagpadayon man gud siya because of the time, dili siya kuan, no. There's just a sequence of frames that we thought sumpay to siya, but however uh, discrete to siya, no. Although naa siya time but discrete to siya, kay lahi-lahi man siya og kuan, lahi-lahi man siya og kanang lahi-lahi siya og sito gani kanang scenario ba kung asa siya nahitabo. Although paglantaw nato nagpadayon siya, but for the continuous mura ka galantaw og kanang stage play bitaw, kanang live gyud nga nahitabo where you can witness, no, unsa joy sequence niya nahitabo, no. So just as a discrete sequence of movie frames represents the continuous motion of actors, we often develop discrete computer models of continuous situations. Okay, so again, for continuous model, time changes continuously, while in discrete model, time changes in incremental steps. Alright, so there are steps of the modeling process, no, and there are 6 of them. So the modeling process, this is cyclic and closely parallels the scientific method. So mao siya sa scientific method, but lahi to siya, no, katong na experiment, no, na observation. So scientific method siya, while the modeling process, no, this is parallel ato siya, and the software life cycle pod, no, for the development of a major software project. So although we're just going to discuss here the process or the modeling process, naapoy lain, no, na scientific method, and also SDLC or software development life cycle, which is discussed in your course software engineering. So the process is cyclic, no, because at any step we might return to an earlier stage to make revisions and continue the process from that point. So naay possibility nga maabot sa step 3 and then naay revisions nga mahitabo. So possibly mobalik sa previous step or to repeat again the process. So That is the term cyclic means. So the first step of the modeling process is the analyze the problem. Okay, saan man siya? So we must first study the situation sufficiently, no, to identify the problem precisely and understand its fundamental questions clearly. So mura kag research, no. This is actually same sa mga research studies where they analyze the problem first, no. They study the situation, no, unsay nahitabo dito, like also identify the problem or state or define what are the problems, no, in this system, and understand its fundamental questions clearly. So at this stage we determine the problem's objective, so na ay objective, and decide on the problem classification such as deterministic ba or stochastic. So since after ma-analyze ang problem and then ma-determine ang objective, no, after na din ana we can decide, no, unsa siya nga unsa siya nga uh, klase sa model. Is it uh, stochastic ba siya, deterministic ba siya, and so on. So only with clear, precise problem identification, we can translate the problem into mathematical symbols and develop and solve the model. So after we have a clear picture, no, and precise problem identification, diha na dayon, no, maunsaon na to pa siya pag unsaon na to siya pag uh, solve sa problem and unsaon pag-implement. Ikaduha is to formulate a model. So in this stage, we design the model, forming an abstraction of the system we are modeling, and here are the tasks, no, of this step. Okay, so first is to gather data. So need jud, no, sa SDLC actually naamon po ni sa software development life cycle, and part siya sa uh, gathering of requirements or system requirements. So uh, to formulate a model, first we're going to do is to collect the relevant data about the system's behavior. Okay? So for example sa katong a tornado, no? Uh, or yeah, tornado. So buhatan siya model. So to gather the data, no, we should have, or we should observe there should have an information, no, about the behavior, no, uh, of the sito gani of the event. And ikaduha is to make simplifying assumptions and document them. So in formulating a model, we should attempt to be as simple as reasonably possible, no. So we frequently decide to simplify some of the factors, and also to ignore, other factors that do not seem as important. So dili tanang factors dapat i-appeal, no. Kung for example buhatan na to og kuan ang model, for example ang humay, so that we could identify the or we could classify unsa siya nga kuan, unsa siya nga klase nga humay nga liso, or what is unsay quality niya. There are complicated, no, variables nga dili na ang i-appeal. Siguro ang i-appeal lang dito ang color, ang size, no, and some other important, no, nga makita, important variables nga makita nato sa kuan humay, so that ma-determine, no, sa system unsay quality ato niya. Okay, so siguro wala na ilabot dito ang kuan ang unsa kadaghanon ang tubig nga gibubo, and ang vitamins. So medyo complicated pa to siya. So maybe in develop nga kuan or future development sa imuhang model, pwede na to siya idungag na dayon. But in as nagsugod pa, you can just use those simple variables. And most problems are entirely too complex, no, to consider every detail, no, and doing so would only make the model impossible to solve. Okay, uh, or to run in a reasonable amount of time, no, on a computer. So simplify or i-simplify lang yun, no. But besides simplifying factors, no, we may decide to return to step 1 to restrict further the problem under investigation. So na possibility nga mobalik pagid og step 1 to restrict further the problem under the investigation. So mas i-focus pagid ang problem, no, and to state there the scope and limitation of your system or the model. So letter C is to determine variables and units. Now we must determine the name and the name that we must determine and name the variable. So identify na to on sa mga variables nga naa diari. So first we have independent variable. This is the variable on which others depend. Okay, so in many applications, time is an independent variable, no? And the model will try to explain the dependent variable. Okay, for example, uh, in simulating the trajectory sa bola, no, time is an independent variable. No, ang height and the distance or the horizontal distance from the initial position, these are the dependent variables whose values depend on the time. No? So given given ang time ani, and then ang distance from the initial position or asa siya gikan gilabay, and then the horizontal distance, no, kung asa siya padulong, will depend on the inigdagan sa time. Dito magdepende ang value niya. To simplify the model, we may decide to neglect some variables. For example, sa may mga variables ato, no, simple ra kayo. Itong model gamay ra kay taglanta, but we should neglect some other variables such as air resistance. No, na ay part ang kon, na ay sa trajectory sa bola na ay factor ang air resistance, no, nga that will affect the distance and the speed of the ball. So treat certain variables as constants or aggregate several variables into one. So these variables, we may treat them as constant. So tagaan lang nato sila constant ka value if ingon ana. So while deciding on the variables, we must also establish their units such as days as the unit for time, no? Kung uh, kuan pod, we can use meters, no, ang distance, or kilometers pa ka, and so on. Letter D, establish relationships among variables and submodels. No, if possible, we should draw a diagram of the model. Drawing on jud, no, breaking it into submodels, no, murag i-divide siya into submodels and indicating relationship among variables. So para ma-simplify ang model, and we must assume, no, or we may assume that ang ubang relationship, no, or some of the relationships are simpler than they really are, no? For example, we might assume that two variables are related, no, in a linear manner instead of in a more complex way. Okay, so letter E, determine equations and functions. So after or while establishing relationships, now between variables, we determine equations and functions for these variables. Okay, so for example, we might decide that two variables are, for example, proportional siya sa matag usa. So we might establish that as a known scientific formula or equation that we could apply to the model. So naay equation or formula nga gamiton if inana ang relationship. So many computational science models involve that is why naa siya differential equations or equations involving derivatives. No, marag lisod-lisod yun eh. So number 3 is to solve the model. So this stage implements the model. So it is important not to jump to this step before thoroughly understanding the problem and designing the model. So problem and then designing the model, no? And then part sa pag-design sa model is you draw and then you divide the model into submodels and determine the relationship, no, of each submodels, and then apply uh, apply the necessary functions or variables. And otherwise, we might waste much time, which can be most frustrating. Some of the techniques, and tools that the solution, it might involve calculus, algebra, graphs, of course, computer programs and computer packages. And our solution might produce an exact answer, or it might simulate the situation. So kung complicated ra kaayo or very complex ang model to solve, again, this is a cyclic process. You can go back to step 2 to make additional simplifying assumptions, or even you can go back to step 1 to reformulate the problem. Okay, number 4 is to verify and interpret the model solution. So once we have a solution, we should carefully examine the results to make sure that they make sense, no? That is why iagi siya og verification, and that the solution solves the original problem, and that is validation. Okay, so process of verification that determines if the solution works correctly. So ang money agian, no, or that is the process para ma-verify nato. So we should determine if or yeah, we determine, no, if ang solution sa problem, no, works correctly, no? And while ang process of validation is that we establishes whether ang system it satisfy the problem's requirements. Okay? So, correct ba siya, and then ni-satisfy ba siya sa problem? That is for verification and validation. So, ang concern ni verification is solving the problem right, no? And validation concerns is solving the right problem. Okay, so testing the solution to see if predictions agree with real data is important for verification. So dapat gina-test, no? Under aning process is that the solution is tested if to see sakto ba ang predictions, no? Given with with the real data. And that is very important sa verification. And we must be careful to apply our model only in the appropriate ranges for the independent data. Okay? So dili siya og masulbad na nimo ni nga or na kay model ani nga for this independent nga variable. That doesn't mean nga it can solve everything. No, for example, our model might be accurate lang siya for time periods, no, for a few days, no? But dili siya true because dili siya true if siya mo agin siya pila ka years. Okay, lahi na po na siya nga model kay tungod sa ka simple sa imong variables, no, mao ra po nga problem ang iyang ma-solve. So we should also analyze the model solution to determine its implications, no, unsa may implication ana niya, or implication sa model. So if the model solution shows weaknesses, balik na pod sa step 1 or step 2 to determine if feasible ba ang imong model. No, so if so, mubalik na pod to the process. So naa siya trade-off, no, between simplification and refinement, no? So dili siya, kung ang target nato is simplification, it might be nga na-sacrifice ang refinement na part, or ang goal is for the refinement, it might be nga naay sacrifices gamay sa simplification, no? So for refinement, we may need to extend the scope of the problem in step 1. Kaya ang simplification man good, gina-limit ang problem, but in refinement, gina-extend ang scope sa problem. So in step 2, while refining, we often need to reconsider our simplifying assumptions. Kung refining man gali, balik ta sa atong assumptions. I-consider nato in simplifying assumptions. And to include more variables. So kung duha ra imong variables, dungagan and assume more complex relationships. Okay, and use more sophisticated techniques. Okay, so lahi ang simplification of refinement. So medyo mas taas-taas na process, no, ang sa refinement. Okay, number 5 is to report the model or report on the model. So reporting on a model is important for its utility. Okay, perhaps the scientific report will be written for colleagues, no, at a laboratory, or will be presented at a scientific conference. So either way, there should have a report on the model, and the report contains the following components. Okay, so maora po siya sa kuan sa modeling process, no, sa report. Another thing sa report, na po siya process. So first process sa reporting is the analysis of the problem. So usually assuming that the audience is mga bright, no, highly intelligent, but sometimes not aware of the situation, we may need, or we need to describe the circumstances in which the problem arises. So there should have description, no? Then we must clearly explain the problem and the objectives of the study. So mo na siya sulod sa analysis of the problem. So sa model design, the amount of detail with which we explain the model depends on the situation. So in a comprehensive technical report, we can incorporate much more detail than in a conference talk. So mas detailed siya. Ang sulod sa model design na siya explanation, or what we called as a detailed nga discussion sa steps sa imong model. So in either case, we should state the simplifying assumptions, the rationale for employing them, and naapoy clear nga label sa diagrams, no, sa relationship among variables and submodels, because it will be very helpful in understanding the model. So third process our reporting on the model is the model solution. So in this section, we describe the techniques for solving the problem and the solution. So unsay methods nga gigamit and giunsa siya pag-solve. So we should give as much detail as necessary for the audience para masabtan nila, and also masabtan nila ang material without becoming kanang mabitin sila ba, no? For a written report, appendices may contain more detail, such as code of programs and additional information about the solutions of equations. So mura siya og kuan. So ang process day sa pag-report, no, mura siya og uh, papel no sa thesis. So inana siya similar, but medyo kuan lang ang thesis, mas daghan pa siya og kuan uh, steps or process nga gi-follow compared ani kay patraman. And within each of this process no medyo gamay-gamay ra og kuan subtopics nga i-discuss, but sa thesis daghan kay siya. Sa chapter 1 na ay background of the study, na ay theoretical framework, na ay conceptual framework, na ay statement of the problem, and so on. So inana. So number 4 ay alright, before that no, napaday kuan additional sa written report under the model solution no. Again, appendices and the code of the program and the solutions sa equations. Okay? And last reporting on the model is the results and discussions. So, ang report, that should include results. No? Na ay interpretations, na ay implications, na ay recommendations, and conclusions sa model solution. So, usually, we present some of the data and results in tables or graph. So, naka-table, naka-graph ang pag-present di ari. So, such figures should contain titles, sources, and labels for columns. So, we may also include suggestion for future work like recommendations. Okay. So, next is the last process or the last step of the modeling process is the maintain the model or maintenance, model maintenance. So as the model solution is used, it may be necessary or desirable to make corrections, improvements, or enhancements. So in this case, the modeler again, balik na po siya through the modeling process to develop a revised solution. Okay, so just to maintain no, if there are bugs or errors that needs corrections sa code or any improvements or enhancements nga makita. So, muna siya part sa maintenance. Okay, so again, the process of verification determines if the solution works correctly. Okay, while ang process of validation establishes if the system satisfies the problem requirements. Although, gidescribe nato ang modeling process as a sequence or series of steps, we may be developing 2 or more steps simultaneously, no? So, naay times nga diretso-diretso, naay times nga magbalik-balik. So, for example, it is advisable no, to be compiling the report from the beginning. So, otherwise, we can forget to mention significant points. So, sa sugod pa lang, gina-compile na ang mga reports, no? Such as or else we will forget no we tend to or we can forget to mention no in the later process, such as reasons for making certain simplifying assumptions or for needing particular refinements. Okay, so also within modeling teams no katong involved aning kuan modeling. So, individuals or groups frequently work on different submodels no, simultaneously. No? Having completed a submodule, it is actually good no if bulag-bulagon ang bulag-bulagon ang task, and a team member might be verifying the submodule while others are still working on solving there. So, pwede lahi-lahi og task para dali ra mahuman ang problem. Alright, so I think yeah. So I think this is the end no for this modeling process discussion. So all you have to do next is to do this exercise. Alright, and you may, okay, so let me just discuss for a while para masave time. You have to compare and make contrast of the modeling process with the scientific method. So you just have to compare and contrast these two, ang modeling process of scientific method. So na-discuss na nako ang modeling process, but the scientific method mo ni ang process. So make observations, formulate a hypothesis, develop a testing method, and so on. So mo na process ni scientific method. Or yeah, so you just have to compare and contrast. So number 2, also to compare and contrast ang modeling process of SDLC. So sa software lifecycle, mao ni siya ang steps, analysis, design, implementation, testing, documentation, and maintenance. Okay, so compare and contrast. And lastly is to research at least 5 examples of uh, a computational science that applies modeling in a real world problems, and also cite your sources. All right, so you may message me for queries and questions about this module or about this quiz through Messenger or through the message in the Quipper. And mao lang to. Thank you.